Okay, so coming back to this then, we've talked about the membrane, okay. We know that in the dark, okay, we are depolarizing the membrane because we're pumping sodium out, pumping potassium in, but because of the sodium channel, we're allowing the sodium to come or diffuse back down through into the cell, and so it's now depolarizing, okay. It's not completely depolarizing though, it's moving from about minus 70 millivolts to minus 40, okay, so it's not generating action potential. What it is doing is it's passing the message down through that cell, and we are releasing a neurotransmitter, which is glutamate. And if you remember, glutamate we said was an inhibitory neurotransmitter. So let's have a look at the next issue then. So now we're going to talk about what happens in the light. Okay, so going back then to our membrane, and you remember that inside our membrane, or inside the actual cell, we've got these membrane-bound vesicles, and embedded into those vesicles is this protein called rhodopsin. And so rhodopsin is a lipoprotein, okay, opsin, which makes up the majority of this, okay, so it's a big lipoprotein, it makes up the majority of this particular protein, and then attached to it is retinol. And it comes in these two forms, okay, so it's an isomer, it's in a cis form, and it can change into a trans form, okay. So, in the light then, we have our rhodopsin, sorry, in the dark, we have rhodopsin, okay, they're joined together. When light strikes the rhodopsin, okay, so we have a photon of light, what it's going to do is it's going to take the retinol, okay, and it's basically going to make it change its shape. So it's going to go from its cis form into the trans form. Okay, so it's going to have a change of shape, and it means that it's no longer going to be tightly bound to opsin, and so the bond is actually going to break. Okay, so I'm now going to be left with opsin, and I'm left with trans retinol. Okay, what the opsin is going to do is it's actually going to come and attach to this membrane. Okay, so the opsin comes up, it's going to attach to the membrane, and once it's attached to the membrane, what it does is it basically brings about a closure to this particular channel. So now what I'm doing is I'm actively pumping sodium ions out. Okay, I've still got actively pumping potassium in. There will be a potassium channel where some of those potassium ions will also be diffusing out, but none of the sodium is going to be able to pass back into the cell itself. And so in effect what I'm doing is I'm actually hyperpolarizing, okay, the membrane. Okay, so it's now hyperpolarized. What that means is that now I'm no longer releasing the neurotransmitter glutamate. Okay, so the neurotransmitter is no longer being released by the vesicles, it's no longer diffusing across the synapse and attaching to the receptor. Okay, now there seems to be two kind of different theories as to what's happening here. In the old textbook, literally what they said was that no neurotransmitter was released. Okay, so nothing is being released here, and because the bipolar cell is no longer being inhibited, an action potential is set up, and then this is then passed on to the ganglia cell.